Cool. Hello, everyone. Just a quick sound check. Can all of you hear me well? Okay, I see a lot of thumbs up. Great. Cool. Thanks for showing up, and I hope you will find the talk interesting and insightful. Maybe just to get to know each other well. How many of you are Java developers? Wow, amazing. And how many have you tweaked the garbage collection in the last 6 months? Yeah, there are a few. Not bad. Cool. So about me, I'm Usama, staff engineer at Get Your Guide. Today I'll be talking about the importance of Java garbage collection in microservices specifically. Cool. So before we dive deep into the topic, let me give you a bit of an introduction to Get Your Guide. So what Get Your Guide does is a marketplace for unforgettable experiences. Since weekend is around the corner, now is the time to basically download our app, use it, and find those unforgettable experiences in Amsterdam. And if you're looking for the discount code, just reach out to us after the presentation. We'll get something for you. Cool. So Get Your Guide, like any other company, started with a monolith. Everything was working well. But during pandemic, when we basically had no bookings coming in, it was like zero bookings. The company decided to, instead of shutting down the operations, we decided to, okay, let's prepare ourselves for the post-pandemic travel needs or travel demands. So what we did, we split one big fat monolith into hundreds of microservices, and now hundreds of engineers at Get Your Guide are working with those hundreds of microservices. Cool, enough about Get Your Guide. Let's talk about why I'm here today in 2025 discussing garbage collection in microservices. So while building the new microservices at Get Your Guide, we encountered several issues, and the underlying root cause was always us neglecting the importance of Java garbage collection. So we were under the same impression as this cute little girl here who thought that when things will go wrong, garbage collection will trigger in and will save the day. Unfortunately, things didn't go as per plan, and that neglect actually led us to things like stability and reliability issues. So we encountered issues like out-of-memory errors and our services, crashing, restarting, not the most, the things that you want or you want your services to operate. Another thing was that since those services were placed in a very critical path, so sometimes, major operations of the platform were affected. Let's say travelers were not able to search, or they were not able to check out. Another thing is the performance impact. We noticed that due to not the efficient garbage collection process kicking in the background, we faced latency spikes, and then led to not the ideal customer experience from the platform perspective. Cool. Now, before I dive into some of the use cases about garbage collection that we encountered in our services, let's take a quick detour and refresh our memory around garbage collection so that when we get to the use cases, all of us are on the same page. So garbage collection, in short, is a process that reclaims the memory by disposing objects that no longer in use. And if you want to visualize this in your mind, then this could be the best picture to summarize that. Imagine Undertaker showing up, picking up all those unreferenced objects, and then just disposing them off. In terms of the benefits, what it brings is automatic memory management. So like the process kicks off automatically, you don't need to set anything explicitly, and it runs, and most of the time does the job. Second thing, as it's reclaiming memory on predictable intervals, you are not getting ending up with memory leaks. So that's also another thing. Then, like we discussed what garbage collection is, but then Java garbage collectors you can imagine as the actual components that kicks in that process or that executes the Java garbage collection process. And there are several of them. So from the slide where you saw Undertaker, so we have John Cena as well, basically. So now we'll talk about the differences between those. First one, the simplest one, the serial garbage collector, single thread, and does the job, execute one garbage collection event at a time. Good for small applications, development environments, or testing environments. For those sort of scenarios, you can use it. The next in line, parallel garbage collector. It overcame the limitations that we had with the serial one. Now you have multi-threads coming in, doing the garbage collection for you. The major focus here is to optimize the throughput. So if you have applications that really needs that and can afford the pause times, because this garbage collector is considered at stop the world, so it will pretty much stop everything else when it gets to the garbage collection. Then the garbage first G1. This brings the best of both worlds. It brings the right balance, basically, so you have good throughput as well with little pause times. Good for situations where your application needs large amount of memory and works most of the time. Last one, ZGC or Z garbage collector, designed to basically provide support for the applications that really needs that low latency and that works with large heap sizes. So good for something that really needs that high responsiveness, analytics or streaming sort of applications or services. Cool. Now the ground is set. We have the basic understanding of Java garbage collection. We know different Java garbage collectors. Now let's go through some of the case studies, some of the real scenarios that we encountered at Get Your Guide while working on different services. What happened? How did we figure out? How did we solve it? Let's discuss that. And the first service that I have here to showcase is the search service. Search service main mission is to provide incredible search experience to our customers. So when they go to Get Your Guide, they are able to search their favorite activity, and hopefully they book it and enjoy it. The requirements for this one is basically that it should be low latency, imagining millions of travelers coming in, searching for the activities. So it needs to be really low latency. And what it does in the background is it aggregates large amount of data from different sources and then stores them in Postgres and Elasticsearch, and then provides APIs to retrieve that data back. So all good so far. So now let's talk about what went wrong. On one of the nice weekend, I don't know why these things always happen over a weekend, but yeah, it was like that. We saw spikes in Search API. The latencies were going crazy. We noticed timeouts. We were not able to connect to Elasticsearch. That's what happened over the weekend. Our monitors started sending us alerts. Some of the alerts here, you can see 20 spikes for about 10 minutes, ultimately leads to like 100 minutes of downtime. Next one, the infamous 500 errors. We saw like a spike of 500 errors coming in, which you can translate to that customers not able to get back the search results that they expect. Root cause or immediate actions that we took. The most sensible one that I expect every one of you would do is basically go increase the resources, increase the number of pods, and that's exactly what we did. It provided us some bandwidth, like a couple of days before we get into the similar situation again. We also noticed that the additional pods could only work up to certain limits, and after receiving more than 700 requests per second, they also started to restart. And when we investigated the logs, it revealed any developer's worst nightmare, the out of memory. Then let's now go into the root causes. First one, that what we noticed is that our garbage collection pauses were both frequent and long. So we saw garbage collection running very frequently and for a long period of time. And as mentioned in the beginning, like the rest of the people, we also ignored garbage collection in the beginning. So what we had basically was the default settings, which was the G1 GC in this case. Although it's like very effective, but in this scenario, we noticed that the tail is like it caused tail latencies to go crazy due to this frequent running of garbage collection. And these frequent pauses, although that the pause time is relatively low in G1, but in this particular scenario where you have large number of requests coming in, those frequent requests also led to cancellation. Cancellation led to retries, and then ultimately end up creating a snowball effect. And at some point, we just ran out of memory and not able to serve more requests. Solution. So now we had to basically pick some other Java garbage collector. The default stuff was not working well for us. So we thought, OK, let's take a step back and see what the search service does. So one thing that it does, it processes large request traffic. It has a huge data set to retrieve. So imagine like you're searching for, show me the things that I can do in Amsterdam. And now there's a lot of data to process, right, based on what you're interested in. Then it brings all those up, ranks, paginate, things like that. So it performs memory-intensive operation on the data that's retrieved, which means that it also needs a large heap to work with. Now, if you recall from the slide of the ZGC, I mentioned that ZGC is focused on providing support for the applications that really needs that low latency and that large heap sizes. So that was the choice for us to let's now go and try ZGC and see how that performs under the similar situation. So what did we notice? That immediately when we moved to ZGC, it reduced the tail latencies, and in the behind the scenes, what happened? Less garbage collection pauses leads to less cancellations, lead to less retries, eventually means less traffic on the service. Then we also noticed that under the same CPU and memory that we had, the ZGC was giving us all these benefits without using further CPU or memory. So it solved the problem, but also was efficient because it pretty much provided us the result that we were looking for without actually utilizing more resources. So for us, this was the new kid in the town, or you can say that one garbage collector to rule them all. So at this point, ZGC became the famous kid at Get Your Guide. Every other service started using ZGC, and that's where the next lesson comes into the picture. That there's no one size fits all. And now let's talk about the inventory service. Now, inventory service core mission is to provide up-to-date availability and pricing information so that when you're looking for something, you can see how the availability looks like, what are the pricing, and stuff like that. What it does behind the scenes, it consolidates the availability and pricing information from different channels, APIs, portals, and then provide APIs so that at the runtime, we can check if the tour is available or not. And the catch here is that this service needs to provide availability of up to 16 months. So it's not that the traffic is high, but the amount of data that's returned or the object size is huge just because it's like 16 months of availability in one shot. Again, what went wrong? Again, another weekend, we were enjoying the weekend, and all of a sudden, we started receiving alerts from our monitors. We saw huge spikes in the memory usage and OM errors as well. Upon investigating, like this time, obviously, we were like better equipped. We know what things to look into. We saw that large objects were occupying a huge memory in our heap, and they were not being garbage collected frequently. So we noticed like these large objects, they shouldn't be here anymore. Like why they are here still? And then when we looked into the garbage collection cycles, we noticed that it's not running that frequently, which is why these objects are still lying there. So why ZGC did not work in this scenario, considering like it really scaled well in the search service? The first thing is the low garbage collection pressure. So what happened behind the scenes that heap size was not growing as rapidly as in the search service case. So ZGC thought, OK, fine, there's no need to run this frequently. So no need to unnecessarily pause the application. Let the application serve the traffic as we can still handle it. So what this led to like those large objects still occupying space in the memory. And then during the unexpected spikes or like when the large amount of traffic came in, we noticed that the ZGC has to start with the high baseline just because those large objects were still in place. so the memory was already high. And then when it started to receive the traffic, it started running the GC cycles or garbage collection cycle process quite frequently, utilizing more CPU, more memory, and then ultimately crashing the service, leading to OOM. So solution in this case, going back to G1GC, because G1GC, if you remember, provides more predictable process, more predictable garbage collection cycles, which was really needed in this particular example. We were not looking for very low latency, right? What we were looking for is to provide, stability for the service. And when we moved to G1GC, we noticed that garbage collection was performed on frequent cycles, garbage was collected, and we did not see those large objects then anymore in our memory. So lesson learned, there's no one size fits all. You need to make sure that you understand your service internal workings and then accordingly choose the right garbage collector according to the service. Cool, now let's talk about the lessons learned. I'll just wrap it up after that. The most important one that was clearly evident is the impact of neglecting the garbage collection. So what happens when you roll out the services, like at that moment they run really well, right? It's only like when they build up, when there's traffic coming in, when your system reaches new highs, you have more traffic coming in, that's where the issue starts to happen. And at that moment, and if the issues start taking place at that moment, it means that your service is already in the critical path. Now there are other services depending on you. So that might not be the ideal time to now solve garbage collection issues, considering there are other teams, other services now depending on your service as well. So important learning, when you're designing services, take out some time, 30 minutes, 1 hour, and think about whether the default garbage collection settings are enough for this service or there's something else that we should be trying. Another important thing from our learnings, especially you notice like in an inventory service, in the case when we received alerts, we had better visibility in place. We knew we had monitors, alerting metrics around how frequently the garbage collection cycles are running in. And that immediately led us to this, that since it's not running that frequently, it means that the garbage collector that we have selected for this service is not providing the best results. So monitoring is really important so that you can easily identify those early signs that maybe this garbage collector is not running well for your service. And last but not the least, like we noticed in inventory service, that there's no one size fits all. You always need to go back, see your service internal working, and figure out what's best for the service. And with that, I hope the session was insightful. I hope this will encourage you to go back, review your garbage collector selection choice, and hopefully you won't have to spend weekends like we had to figuring out what's going on. And if you enjoyed what you saw, and if you are also someone like me who loves to solve similar challenges, then we are hiring. Thank you, everyone.